Okay, so you've given us quite a challenge this time, tackling Spinoza's physical theory. A
Uh,
system built in the 17th century, clearly drawing from Descartes,
yeah,
yet also carving out
yeah,
its own, sometimes really perplexing path.
yeah.
For our listeners out there, the philosophers, the ones who really love to get down to the nitty-gritty of complex ideas, our mission today is to really dissect the core of Spinoza's physics. What are the driving forces behind it? What are the points where it seems to falter? And what's its lasting philosophical significance?
Right. And our main source material for this deep dive will be excerpts from the Stanford Encyclopedia of Philosophy's entry on Spinoza's physical theory. It's a really in-depth scholarly analysis.
It is.
So we're not aiming to just give a summary here. We really want to unpack the key elements of Spinoza's thinking, trace how it connects to and diverges from Descartes, and confront some of the major interpretive challenges that it presents.
Yeah, and I think it's so important to kind of place Spinoza within his historical context, right? He's writing during this really turbulent intellectual period, kind of sandwiched between the waning influence of scholastic philosophy and the rise of what would become Newtonian physics and Baconian experimentalism.
Yeah, you've got it.
But as our source emphasizes, he didn't really fully embrace any of those dominant approaches. He was famously critical of occult qualities and, really skeptical of pure empiricism. His approach is very much grounded in rationalism.
Definitely. So where do we even begin with unpacking Spinoza's physical world?
Well, I think a natural starting point is looking at the Cartesian roots of his physics, right? Understanding where he agrees with Descartes kind of gives us a backdrop against which his unique and sometimes radical ideas can really stand out. I like that. So our source tells us that Spinoza, much like Descartes, conceived of body as res extensa, that basic notion of extended substance. They both rejected the idea of a vacuum. They adhered to this plenist view of the universe where space is entirely full. Spinoza also adopted a lot of Descartes' kinematic principles, the laws that describe physical phenomena. And really importantly, both thinkers dismissed teleological explanations in physics, so no invoking final causes or purposes in nature.
Okay, so we've got some clear points of alignment.
Yes.
But for a really nuanced understanding, we need to recognize that some of these agreements kind of mask deeper, more fundamental metaphysical divergences.
Oh, okay, interesting.
So, for example, they both reject final causes, but their reasons are profoundly different.
Yeah.
Descartes' rejection stems from what you might call an epistemological limitation, basically a limit in our ability to know. He argued that our finite human minds can't really grasp the purposes of the divine will, even if they exist.
Okay, so for Descartes, it's about what we can know. But Spinoza's taking a different stance, right? Something more fundamental.
Yeah, exactly. For Spinoza, the rejection of final causes isn't about the limits of human understanding. It's about his metaphysics. His concept of God or nature isn't that of a being with a will or a plan, that directs creation. For Spinoza, nature just is. It operates according to necessary laws, not some predetermined end.
So that's a huge difference. It's not just about our capacity to comprehend. It's about the very nature of reality for Spinoza.
Absolutely.
And it seems like these differing metaphysical commitments extend to areas where they superficially agree, like the laws of nature themselves.
You got it. And this is where Spinoza's Principles of Cartesian Philosophy, usually abbreviated as PCP, becomes really important. It's where he spends quite a bit of time explaining these Cartesian laws, especially the rules of collisions between bodies.
Okay, but this work is presented as an explanation of Descartes' thought, right? So can we really take everything in it as Spinoza's own mature philosophy?
Yeah, that's a great point, and something to be cautious about as good philosophers.
Yeah.
But Spinoza's choices in how he presents and even tries to extend Descartes' ideas often give us valuable clues into his own developing views.
Right, like our source mentions Spinoza's efforts to extend Descartes' rules for collisions to include oblique collisions.
Yeah.
So Descartes' rules mostly dealt with head-on collisions, right?
Right. Think of bodies moving along a straight line. But in a scholium in the PCP, Spinoza suggests that Descartes' term determinatio, which Descartes used to describe the determination of motion, should actually include not only the direction of a body's motion, but also the force behind it.
Okay.
And Spinoza tries to show how these forces can be resolved into component forces, using what we call the parallelogram rule. This would allow you to apply collision laws to interactions at angles.
But this attempt doesn't quite work out in the end, right?
No, it doesn't, and that's actually really telling.
How so?
It points to a fundamental difference in how Spinoza and Descartes view the completeness of the physical realm and its causal closure.
Okay.
Descartes believed in the conservation of the quantity of motion, but he also thought mental substances could interact with physical bodies, specifically by influencing the direction of their motion.
Oh, interesting.
So for Descartes, the physical system wasn't totally self-contained,
Sure.
which means that maybe a universal set of purely physical laws for all collisions wasn't strictly necessary for him.
Because there could always be those outside mental influences intervening in the physical events.
Exactly. Descartes wasn't a strict physical determinist in the way that Spinoza would become. Spinoza totally rejected mind-body interactionism. For him, nature was a completely causally closed system.
Right. As he famously states in Ethics IP 28, every event is determined solely by other modifications of extension and the laws governing them.
Exactly. So this commitment to a self-sufficient physical domain probably made the need for a more comprehensive and general set of collision laws much more pressing for Spinoza.
I see. So while Spinoza might have adopted Descartes' rules in the PCP, he couldn't have accepted Descartes' theological justification for them. It all rests on the immutability of God's will. Spinoza's God or nature doesn't operate through will in that way.
Right.
This brings us to another key concept that Spinoza inherits from Descartes, the principle of least modal mutation.
Yeah.
Can we break that down a bit?
Sure. It's often called PLAM for short. This principle actually comes from a letter that Descartes wrote. He basically says that when colliding bodies have incompatible modes, think of modes as properties or ways of being, some change has to happen to make them compatible. But that change will always be the absolute minimum needed.
Okay.
And what's interesting is that Descartes never really spells this principle out or justifies it in his major work, The Principles of Philosophy.
But Spinoza picks it up in the PCP, right?
Yeah, he does. He includes it and tries to demonstrate it in PCP IIP 23. He claims that when a body's modes are forced to change because of something outside the change, it's always going to be the smallest possible. And his proof for this relies only on PCP IIP 14, which is his version of Descartes' law of inertia. A simple thing considered by itself stays in its state as much as it can.
And our source points out a potential problem with this demonstration, a kind of logical gap.
Yeah, a really important one.
What is it?
So PCP IIP 14 is about a body considered in isolation, nothing acting on it.
Okay.
But PCP IIP 23 deals with bodies interacting and being forced to change because of outside things. So it's not obvious how the tendency of a body to persist in its state when it's alone directly leads to the principle of least change when it's interacting with other bodies. It's totally possible that the least overall change for the whole system might require one body to change a lot more than it would if it were just by itself.
I see. So that's a problem with Spinoza's early attempt to ground PLMM. And if Spinoza couldn't use Descartes' theological justification for inertia, relying on God's will, and his early attempt to link it to PLMM seems shaky, how did he end up understanding inertia?
Okay, well, Spinoza actually lays out his own principle of inertia in the Ethics, specifically in the physical interlude that follows Proposition 13 of Part 2. He says, a body in motion stays in motion, a body at rest stays at rest unless another body acts on it. What's really interesting here is that his proof for this seems to be purely rational, no appeals to God or anything like that.
So the source quotes his argument. If a body is at rest and nothing is acting on it, we have no reason to say it'll start moving. Any change needs an external cause.
Exactly. And since the very idea of a body at rest or in motion, when you think about it alone, doesn't have any reason to change to the opposite state, you need something from outside to explain that change. Spinoza even calls this principle of inertia self-evident.
Okay, but for a hardcore rationalist like Spinoza, wouldn't it be unsatisfying to just accept inertia as a basic fact? Wouldn't you want to find a deeper reason for it?
You're absolutely right. Just taking it as a given wouldn't really fit with his whole philosophical project. He'd be adopting a central Cartesian principle without Descartes' original justification and without offering a clear alternative.
That makes sense. So this leads us to that subtle but potentially significant shift in language that Spinoza uses in the PCP when he talks about centrifugal motion.
Okay, now things are getting really interesting philosophically.
Okay.
So in PCP IIP 16, when he's describing a body moving in a circle, Spinoza says it's continuously determined to go on moving along a tangent, basically in a straight line away from the center. But then in the very next proposition, PCP IIP 17, he describes a body in circular motion as conare, to move away from the center. He switches out the Latin verb.
And conare means?
It means to strive. It's stronger than just to tend or to incline, which is what Descartes used. So it seems to suggest an active effort or impulse rather than just a passive tendency.
So if we interpret Spinoza's conare in that active sense, then PCP IP 17 isn't just describing the result of a body being forced in a circle. It's attributing the outward motion to something inside the body itself, a kind of active tendency.
Exactly.
But hold on, our source also mentions that Descartes sometimes used contrary in a more passive way, just to mean that a body is positioned in a way that it would move unless something stops it.
That's true. And it's important to keep in mind when we interpret Spinoza.
Yeah.
In Principles 3.56, Descartes specifically defines this striving in inanimate objects as just being situated in a way that they'd move if nothing got in the way. And Spinoza actually echoes this passive understanding of Connery in PCP 33 when he's explaining Descartes' views on hardness and fluidity.
So why is this use of Connery in PCP IAP 17 still potentially important for understanding Spinoza's own ideas?
Well, because Connery is also the root of Spinoza's big concept of conatus, which appears in the Ethics. It's the inherent power of a thing to persevere in its own being.
Right. Ethics third.
Yeah, exactly. And in the Ethics, Spinoza says that this conatus is basically the essence of the individual P7. He argues that the more conatus a thing has, the more power it has to act and determine itself.
Okay.
So this connection between the Canary and the PCP and the later conatus in the Ethics suggests that Spinoza might have already been thinking of inertia as something more than just a passive consequence of a body's nature or a law set by God. He might have been hinting at a more active internal principle.
And if inertia is this active, striving to maintain its state, how could that connect back to the principle of least modal mutation, the PLMM?
Well, think about it. If each body actively strives to maintain its current state, then when they collide and are forced to change, they'll resist that change as much as they can.
Okay.
The resulting change in the whole system would then be the smallest total change possible. It's like a balance or a resolution of these opposing strivings, where each body only yields as much as it absolutely has to because of the forces acting on it.
This takes us right into the concept of conatus in Spinoza's mature philosophy as presented in the Ethics.
It does Ethics the IP6, where Spinoza defines conatus. Each thing strives to persevere in its own being, has been a source of a lot of debate among philosophers.
Yeah, the whole idea of striving to persevere seems to suggest a goal, a purpose.
Exactly. And Spinoza uses conatus a lot in his psychology. He says human beings strive to get things that increase their power and avoid things that decrease it.
Right.
It sounds a lot like teleology, where a future state like increased power is the goal that directs present actions.
But Spinoza explicitly denies that nature is teleological, right?
Yeah.
In the appendix to Part 1 of the Ethics, he says that teleological explanations are just us projecting our own desires onto nature and getting cause and effect backwards.
Exactly. That's crucial to remember when we're thinking about conatus. And then there's Ethics IP28, which seems to say that everything is completely determined by external causes.
It says every single thing is determined to exist and act by something else, and that thing by something else, and so on forever.
Yeah, so where does this internal striving, this conatus, fit in? How can Spinoza deny teleology and also say that everything has this drive to self-preserve?
It seems like a contradiction.
It's a tough one, and scholars have been wrestling with it for centuries. One way to approach it is to think about what Spinoza means when he says in the Scholium to IP13 that a body's nature contributes to how it's affected by outside causes. Maybe the idea of an active conatus, a striving to keep its state, could explain why a body resists some influences more than others. It could be the internal principle that helps a body stay together and not dissolve when external forces act on it.
Right, like our source mentions Edwin Curley's interpretation. He says conatus could be a body's resistance to being broken down into a simpler state.
Exactly. Curley argues that a body has a certain organization, a coherence, and its conatus is its tendency to keep that organization and resist being broken apart or forced into interactions that would mess it up.
And there's also Carriero's interpretation, which tries to understand conatus in a way that's not teleological. He says it's about individuals maximizing their being because they're stable in the plenum.
Yeah, Carriero says this tendency to persist and stay whole isn't driven by a conscious goal or purpose. It's just a consequence of what it means to be a stable individual in Spinoza's fully interconnected reality.
Individuals that are more stable are going to last longer and thus look like they're striving to stay alive.
Right, but even this raises the question of what makes them stable in the first place.
Yeah, that's a good point. So all of this leads us to the really fundamental question of how Spinoza thinks about bodies, especially since he rejects Descartes' idea that they're independent substances.
Absolutely. This is where Spinoza's radical substance monism comes in. He famously argues that there's only one substance, which he identifies with God or nature, and that all finite things, including bodies, are just modifications of this one substance.
And for bodies, that means they're conceived under the attribute of extension.
Exactly. They don't exist independently like Descartes' mind and body substances did.
This is a huge departure from Descartes.
Yeah.
So what was Spinoza's motivation for this move to monism?
Well, our source suggests that Spinoza saw problems with Descartes' definition of substance.
Okay.
Descartes said a substance is something that doesn't depend on any other created thing for its existence. But Spinoza argued that only God truly fits that definition.
Right.
Descartes thought finite substances like minds and bodies only depended on God, but Spinoza thought that was a bit of a cheat. For Spinoza, true independence was the defining feature of substance, and anything finite and created can't be truly independent.
So in Spinoza's system, bodies are demoted from substances to modes.
Yeah.
But what does that actually mean for how we understand them?
This is where we run into a big debate among Spinoza scholars. Traditionally, substance means two things.
Okay.
First, it means independence, which we just talked about.
Right.
And second, it means being an ultimate subject of predication, meaning something that has properties, but isn't itself a property of something else. The question for Spinoza is whether his modal view of bodies means they're not ultimate subjects anymore.
So are bodies for Spinoza just ways that the one substance of extension shows itself kind of like adjectives describing reality?
Yeah.
Or do they still have some individual reality even though they depend on the one substance for their existence?
That's the heart of the debate between what we call the adjectival and the subjectival readings of Spinoza's modes. The adjectival view says bodies are just ways that extension is modified. This often goes along with interpretations that sees Spinoza's physics as a kind of field metaphysics, where bodies emerge from variations in a unified field.
Yeah.
But the subjectival view says bodies are still individual things, even though they're not independent substances. They're the ultimate subjects of their own properties, like motion and rest.
The source points out that Spinoza often calls bodies individuals and things, which seems to support the subjectival view. It suggests he saw them as having some distinctness.
Yeah, but then the word mode itself seems to lean toward the adjectival interpretation. It means a way that something else exists.
Right, so the adjectival view has to explain how these mere ways that extension exists can seem like distinct things that interact causally. And both views have to deal with the problem of individuation.
Exactly. How do we tell bodies apart in Spinoza's system, and how do they stay the same over time when they're changing and interacting?
And that takes us to how Spinoza himself tries to address this problem of individuation, especially compared to the issues he saw with Descartes' account.
Yeah, so Descartes famously said that all the variety in matter comes from motion. But then he defined motion as the change in position of one body relative to other bodies.
So you need distinct bodies to have motion, but you also need motion to have distinct bodies.
Exactly. It's circular. And Spinoza knew this.
Yeah.
In a letter to Schernhaus, he explicitly says that you can't prove the variety of things just from the idea of extension.
So he saw a limit in Descartes' attempt to define matter just through extension.
Right. And in the same letter, he suggests that maybe we need another attribute, something that expresses an eternal and infinite essence to really account for the individuation of finite things.
That's interesting.
Yeah, and he even says he wishes he had the time to work all of this out more systematically in his writing.
So maybe the physical interlude after Ethics Die P13 gives us some clues about his own solution, even if it's not fully developed.
Possibly. The physical interlude is definitely Spinoza's most detailed discussion of bodies and individuation, but on first glance, it seems to have a similar circularity to Descartes' account.
How so?
Well, definition 1 of the physical interlude says that bodies are distinguished from each other by motion and rest.
Okay.
But then definition 5 defines a body or individual as something made up of multiple bodies that are connected and share motion.
So you need multiple bodies to define an individual body.
Yeah, and it gets even more complicated because Lemma 7 and its scholium say that the simplest bodies are distinguished only by their motion and rest.
It sounds like he's saying motion and rest are what make bodies distinct, but motion and rest are also things that bodies have.
Exactly. It seems circular, and it's led to a ton of different interpretations among scholars.
Like what?
Well, for example, Clever argues that we shouldn't think of extension as this static thing that then gets put into motion. Instead, he says the fundamental reality is matter in motion, where motion and rest are the primary expressions of God or nature, and bodies emerge from these patterns of motion.
That's interesting.
Yeah, it's trying to address Spinoza's suggestion that we might need another attribute to explain variety.
And this also leads to different interpretations of what motion and rest actually mean in the physical interlude.
Right. If it's not the motion and rest of already existing bodies, what is it?
Yeah.
Clever compares it to modern physics, where mass and particles are seen as coming from fields of energy. It's an anachronistic comparison, but it might help us understand what Spinoza was getting at. Bennett, who sees Spinoza's physics as a kind of field metaphysics, suggests that motion and rest might be placeholders for some basic physical property that exists across a four-dimensional field. Bodies would then be stable patterns of this property.
Like that analogy he uses of a fall line receding across a snowy landscape. The line itself isn't a thing moving. It's just a changing boundary that shows which areas are still covered in snow.
Yeah, that's a good one. But our source points out that this analogy still depends on our idea of melting ice, which is a physical process, so it might not help us get beyond bodily concepts.
That makes sense.
Garrett tries to make Bennett's idea more concrete. He says motion and rest could be quantities of force, one that causes movement and one that resists it, and these forces would belong directly to the substance of extension.
Okay, but the source raises an objection to this. Doesn't Spinoza say in the PCP that force and resistance belong to bodies? So Garrett might still be assuming the existence of bodies.
Yeah, that's a valid point. A common problem with all these interpretations is that they have a hard time explaining how bodies can be so persistent and seemingly active.
Right. If they're just patterns in a field, why do they resist change and seem to strive to exist, like Spinoza says with Conatus?
Yeah, it's a tough one. Phil Johnin tries to solve this by saying extension isn't just a passive expanse, it's a field of power or activity, and bodies are concentrations of this power. Motion is then the transfer of this power within the field. But then the question becomes, what are these powers to do? Saying they're powers to persevere seems circular because that's what we're trying to explain in the first place.
Right. So then there's the whole issue of math and its role in Spinoza's physics.
Yeah.
Gabby has this big critique. He says Spinoza's account lacks quantitative anchoring. He argues that just talking about ratios of motion and rest isn't enough. You need a precise mathematical framework to define those ratios and the units of measurement.
Right. Gabby points out that Spinoza doesn't give us specific laws or equations for individuation. He says without that quantitative grounding, the theory is too vague to really apply to the physical world. And while some scholars like Garrett and Mattson have tried to interpret motion and rest in a more numerical way, it's dangerous to impose modern ideas onto Spinoza's 17th century context.
Right, we have to be careful about anachronism, especially since Spinoza himself had complex views on math and whether it could even be used to understand reality.
Absolutely. He loved Euclidean geometry as a model of knowledge, but in his letters, especially the one to Lodewijk Meyer, he's really skeptical about using measurement to understand the essence of things. He thought concepts like measure time and number are really just products of our imagination, not reflections of the true structure of reality. He saw quantity understood intellectually as this infinite and indivisible unity, which is totally different from the finite divisible quantities that we imagine and measure. This creates a big problem for interpretations that rely heavily on numerical ratios for individuation.
And then there's Peterman's really radical interpretation. He says extension isn't spatial at all, meaning bodies don't take up space the way we think.
Yeah.
But as our source says, this is a really hard view to square with Spinoza's own words and with how we experience the world. It also makes it hard to explain how we imagine space and reinterpret motion and rest.
Right. The more common alternative is that extension is spatial, but we can only divide and measure it in our imagination.
Okay.
This is more plausible, but it still doesn't fully connect Spinoza's philosophy with the math-based science of today.
So looking at Spinoza's views on science, it seems like he wasn't really part of the scientific revolution, even though he might have anticipated some later ideas.
Yeah, his skepticism about using observation as a source of knowledge, his view of experimentation as mostly proving things impossible, and his doubts about using measurement to understand the essence of nature all make him very different from the empirical and mathematical approaches that became modern science.
So as philosophers looking back on this deep dive into Spinoza's physical theory, what are the big takeaways?
Well, we see Spinoza trying to build a rational physics based on Descartes, but with key metaphysical differences, especially his substance monism. There are ongoing philosophical challenges in reconciling a mechanistic worldview with the apparent activity of bodies. And there are lots of debates about core concepts like conatus and individuation. And Spinoza's skepticism about empirical methods and measurement really sets him apart from the direction that science took.
But even with all the tensions and open questions, his theory is still philosophically interesting.
Definitely.
It gives us a unique perspective on big issues like the mind-body problem, causality, and the nature of reality. It makes us question our assumptions about these things.
Absolutely. And this brings us to a final thought for our listeners out there, the philosophers. If Spinoza was so skeptical about our senses and about using measurement to understand reality, how could a purely rational account of the physical world, even with its limitations, challenge or maybe even add to our current scientific understanding, which relies so much on observation and measurement?
That's a great question to ponder.
Yeah. Is there value in approaching reality from this radically different perspective? And what are the limits of a physics based only on reason?
Really thought-provoking questions.
Mhm.
Thank you for joining us on this deep dive into Spinoza's physical theory. We encourage you to keep exploring his ethics and the many interpretations of his work.